Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 7.2 inverse trigonometry ratios. Really cool thing about today, it's a repeat of yesterday.
That's right.
Just a little different. So, what are you going to be learning? Well, by the end of the lesson, you will be able to use the inverse trigonometric ratios to find an angle in a right triangle. So really the only difference between today and yesterday we were finding a missing side. Today, we're going to be looking at a missing angle.
Very cool.
Other than that, everything is very much the same. So
Awesome.
Why are we doing this? Well, knowing how to apply inverse trigonometric ratios will help me to show real life problems when an angle measure is unknown. So if you saw the skateboard video that I showed, that was an inverse trig ratio.
Yes, it was.
So, how will you know you know it? Well, you'll know you mastered it when you can determine the correct ratio given specific information about a right triangle.
All right, let's go ahead and dive in. So just a reminder, SOHCAHTOA is going to be used again today. Sine, cosine, tangent, labeling our opposite, adjacent, and hypotenuse sides. So the first thing we're going to look at is sine. Again, we're going to label our sides. We have our opposite side. Over here we have our angle A is what we're using, so we're going to label BC as opposite, and then we have our adjacent side. The new piece of information today is now what do you do when this is the missing piece? As Mrs. Netz said in 7.1, we were working with, we knew the angle, we knew a side, we were looking for another side. Well, today we're going to know two of the sides. You're looking for the angle. So what that's going to do is when you're missing the angle ends up being equal to the inverse of sine times the opposite over hypotenuse. And where that comes from is if you have sine of theta, we'll divide sine out. It becomes 1 over sine. Well, what is 1 over sine? If we bring it up, sine to the negative first power.
If you'll remember using your negative powers in Algebra 1, so if you remember if we had x over x to the negative second, you knew that you could take the x to the negative 2, take it up to the numerator, and then you change the power to a positive. So basically this is the same thing. The inverse would be 1 over sine, because we were doing sine over 1 yesterday, if you remember.
Yes.
So now we take the inverse. Well,
1 over sine would be sine to the negative first power. So that sine to the negative first power is stating that we divided it out from the other side.
Now, if you look on your calculator, you'll also see your sine, tangent, and cosine buttons all have, in small type above them, sine to the negative 1, tangent to the negative 1, and cosine to the negative 1.
So you need to remember with this lesson today, when you're looking for an angle measurement, you have to hit the shift button on your calculator before doing this, otherwise you will not get the right answer. So in this particular problem, theta is angle A, would be equal to the inverse of sine times the opposite over hypotenuse side. So we would say the measure of angle A is equal to the inverse of sine times side BC over the hypotenuse, which is AB. And the next two are going to be very similar, using what we did in 7.1. Along with this, we're going to now do the inverse of cosine. So remember, cosine, we're going to need to know our opposite, adjacent, and hypotenuse sides. Well, AB is our hypotenuse. If we use angle A, we would say BC is our opposite side, and AC would be our adjacent side. Theta is going to be equal to the inverse of cosine, and then right here we have our SOHCAHTOA reminder, A over H, so it's going to be adjacent over hypotenuse. The inverse right here, the negative 1, just means that we divided the word cosine from this side where it was yesterday to the right side of the equation. So for this particular problem, we can say that the measure of angle A is equal to the inverse of cosine times AC over AB. And then lastly, we have tangent. To do tangent, you need to know opposite, hypotenuse, and adjacent. So for the third time, I'm going to go ahead and label my OA and H over the triangle ABC. theta is going to be equal to, if we're doing tangent, it would be the inverse of tangent. And then we know OA in SOHCAHTOA means I need to multiply it by opposite over adjacent. So we can state, if we were actually solving the problem, that the measure of angle A would be equal to the inverse of tangent times BC for opposite over AC for adjacent. And that is it.
Easy.
So now we can go ahead and flip the page over and work through some of these. So find the measure of theta. So you can see theta is our angle we're missing right here. If we start labeling everything, we know that this 24, I'm going to start the same way we did in 7.1. We can say that that is our hypotenuse. And then from theta, we would label 7 as our opposite side. And then the top horizontal right here is going to be adjacent. You're going to choose sine, cosine, and tangent exactly the same way as we did in 7.1. You're going to look at which sides are you using and which one are you not. In this case, we are using opposite hypotenuse, not using adjacent, so that leaves us with this being a sine problem. Theta is our missing piece, so theta is going to be equal to the inverse of sine, and then our opposite hypotenuse side is going to get plugged in, so 7 over 24. In your calculator, you are going to plug it in literally just like this, but to get this to show up, again, you have to hit shift sign.
So really all you have to do is hit shift, sign, then
Parenthesis.
7, and you can either use divide or you can use your fraction key, and then
24.
put that in. I don't even think they have to do the parentheses.
They don't need to close the parenthesis. I think you do need something here. Your calculator, I think, will work if you do shift sign, open parenthesis, 7 over 24, and then that's it. You don't have to close it. But just rule of thumb, if you write it like this, just type it just like that, and you'll always get the right answer. With angles, I usually like to have you guys just round to the nearest whole number to keep that 3 angles add up to 180 and the complementary angle relationship very simple and obvious for you guys. So what you should be getting on your calculator is approximately a 17-degree angle for theta. Okay, next. If we go through, start labeling everything, 15 is going to be labeled as H. From angle theta here, you are going to label O and A. Because A and H are the two sides you're using, this is a cosine problem. We can go ahead and start plugging everything in. So cosine of angle theta is always equal to adjacent over hypotenuse. Well, because theta is the variable, you would divide cosine out, giving you that theta would be equal to the inverse of cosine, and then you have that 12 over 15 at the end. Type this right into your calculator, and you are going to get that this is approximately a 37-degree angle. And then last but not least, right here, start labeling your sides. AC would be our hypotenuse side. From theta, 42 would be labeled as opposite, while 80 would be labeled as adjacent. Due to the fact that we are saying 42 and 80 are opposite adjacent, that's going to be SOHCAHTOA. So TOA is opposite adjacent, so this is a tangent problem. So the inverse of tangent times 42 over 80 would give us our angle measure, which would be about 28 degrees. So nice short lesson. Hopefully you guys feel confident in how you would do this. So basically there are 3 different ways to use the trigonometry with right triangles. You're either going to multiply, divide, or use shift or the inverse function. And it all depends on where is your variable. Is your variable in the fraction in the numerator, denominator, or is your variable next to your trig function on the left side? So it's really important that you guys are writing that initial equation out to decide how are you going to solve the proportion out. All right, if you have any questions about this lesson, please reach out to us using the methods you all know by now.
Hey, Mrs. Weichel.
Hey, what, Miss Nance?
What do you need to grow your trigonometry skills?
I don't know what.
Oh, duh, square roots.
What about cube roots? Those work?
Oh, I don't know.
Any kind of root?
What about a square root? That's why I said a square root. A cube root? What would a cube root do? Take off and, like...
I don't know.
Weird. You need roots, square
You need
ones.
roots. All right, thank you for joining us. We will see you in the next lesson.
Watch the